In this video, we'll be working with polynomials that contain radicals. The good news is that if you're used to working with polynomials, and if you're used to working with radicals, this video is really going to be absolutely nothing new. Well, maybe a little something new, but not too much. Alright, so let's start off by looking specifically at multiplying binomials. Alright, so if you don't remember what a binomial is, I will tell you right now. It is just an expression with two terms. So for example, if we have 2 root 3 minus root 6, that is a binomial because there is two terms. Alright, so let's say I want to, for example, square this binomial. So as you know, if you're squaring a binomial, you have to multiply each term by each of the other terms, which means this is really, let's see, that. So by squaring that expression, we're multiplying it by itself. So we're multiplying this by itself. And remember, we have to multiply each term here, so the first term by the first term by the last term. So we're multiplying everything. And we learned the acronym FOIL to help us to remember that we need to multiply every single thing by everything else. Alright, so first term by first term gives us 4 root 3 root 3. Plus, alright, it's actually outer, so that times that gives us minus 2 root 3 root 6. Inner, so the inner terms here gives us minus 2 root 3 root 6. And finally, last, so our two last terms, when we multiply, we get plus root 6 root 6. So this has a way to go before it's fully simplified. So that's actually 4 root 9 minus, now notice here we have like radicals here and here, so that is minus 4 root 3 root 6. Boy, that ice cream chuck just keeps on going. Plus root 36. Alright, so we still can go a little further here. Well, we know that square root of 9 is actually 3. So that is 4 times 3 minus 4. Well, here we have root 3 times root 6, which is actually root 18. So let's put that there. Plus, and we also know that the square root of 36 should be 3. So, I mean, not 3, 6, clearly. Okay, so we're almost there. We need a little more space. I'm going to take this problem up to this blank space here and continue working. Alright, so 4 times 3 is 12. So we have 12 up here. Now, we can probably break this down a bit. So root 18 is actually root 9 times 2. So I'll rewrite it that way so we can simplify. Minus 4 root 9 times 2. I'm trying to write really small here. Plus 6. Alright, got this. Alright, so we have 12 minus 4 times 3, and I'm getting that 3 from here. Square root of 9 is 3 times root 2 plus 6. Alright, which is equal to 12 minus 12 root 2. How did I get that 12 root 2? Well, remember the 4 and the 3 gives us 12 when we multiply them. Plus 6. So plus 6. Now we have like terms here and here. So we get 18 when we add the 12 and the 6 minus 12 root 2. Okay, so sometimes you're going to have to do a lot more than just multiply binomials. Sometimes you're going to have to simplify a fraction that has a binomial in it, and then the binomial has a radical in it, and it's all this stuff. But it's not so bad, as long as you know what a conjugate is. So let's talk about what a conjugate is. So let's say I have a expression. Or expression is 3 minus the square root of 5. And for some reason, and we'll see why later, but for some reason we want something called the conjugate. So the example says, find the conjugate of that thing here. So find the conjugate. That's a J, not a G. All right, so now the conjugate is going to be the same terms. So we have a 3 here, we have a root 5 here. It's going to be the same terms, 3 and root 5, but the only thing that's going to be different is the sign in the middle. So a conjugate will always have the same terms, 3 with 3, 5, root 5 with 5, root 5 with root 5, sorry, but the signs will always be different. All right. Well, what is this used for? Let's actually see an example where we see this in use and why we need it. Okay, so here we have an example where we have to simplify a fraction, and the fraction has a binomial, and as I said before, the binomial has a wonderful little radical right there. And remember that our fractions cannot have radicals in the denominator. Radicals are not permitted in the denominator of a simplified fraction. So what do we do then? All right, well, in this case, we have to multiply both the numerator and the denominator by the conjugate of the denominator. So we're going to write that down and explain why. So multiply the numerator and denominator by the conjugate of the denominator. All right, so we have our denominator here. What's the conjugate of that denominator? All right, so hopefully you said that our conjugate is 3 plus root 5. All right, when you multiply by the conjugate of the denominator, what ends up happening is that you end up eliminating the radical. Somehow it magically, wonderfully happens, and I'll show you how it's not magic, it's just math. All right, but whatever you do to the bottom, of course, you have to do to the top, as you know. So we have to multiply the top by the same expression. All right, let's make this happen. Remember, we're going to do first outer, inner, last. I'm going to do it a little quicker than I did it before. All right, so let's just put this here so we can visualize. All right, so at the top we have first times first, 3 times 3 gives us 9. Outer, so 3 times root 5 gives us plus 3 root 5. Inner, we have here root 5 times 3 gives us plus 3 root 5. And last, we have here root 5 times root 5 gives us plus root 25. All right, so that's the top. That's our numerator. Let's do the same for the denominator. First, we have 3 times 3, which gives us 9. Outer, 3 times root 5 gives us plus 3 root 5. Inner, negative root 5, 3 gives us minus 3 root 5. And finally, last, negative root 5 times root 5 gives us minus root 25. All right, now we can simplify this. But the first thing I want to point out to you is the fact that these two guys eliminate each other. which is a very, very useful thing. Okay, so at the top we have 9 plus, like radicals here, we have 6 root 5 plus the square root of 25 is actually just 5. So we have that over 9 minus, and we have root 25 here again, which we know is 5. All right, we're almost there. Now we have like terms, 9 and 5, which gives us 14 when we add them. So 14 plus 6 root 5 over like terms here, 9 minus 5 gives us 4. Okay, so we're almost there. So is there a common factor in this expression? Yes, there is. We can take out of the top, we can take out the common factor 2. So I'm going to write that over here. If we take out the common factor of 2 at the top, 2 into 14 gives us 7, and 2 into 6 root 5 gives us 3 root 5. And that's all over 4. Now we can cancel. 2 into itself gives us 1. 2 into 4 gives us 2. So our actual answer here is 7 plus 3 root 5 all over 2. And we're done.